All right, ladies and gentlemen, we are going to work on Unit 2.5, which is graphing linear inequalities on a XY coordinate system. And that's our goals for today. We're going to graph one of them, or we might see an and or an or, an intersection or union of the two linear inequalities. So as we take a look, first thing we're going to do as we're graphing these on an XY coordinate system is we're going to graph that line, and we want to get it into y equals mx plus b form. But instead of equals to, you're going to have greater than or less than or equal to, greater than equal to. Your symbol is just going to be different. From there, once we have that, just remember if it's greater than or less than, it's going to be a dashed line, which means it's not part of the solution set. And if we have a less than or equal to or greater than or equal to, then it's going to be solid. So again, if it's an equal to on the bottom, it's solid. The last thing we'll do is our shading, and if it's greater than or greater than equal to, we're going to shade above. And then less than or equal to, we're going to shade below. So again, anytime that looks like an L, it's below, below, below. So here we go. We got example one. I got 2x minus y is less than 6. Again, the first thing we're going to do is get into slope-intercept form. So I'm going to go ahead and subtract this 2x over. So now I got negative y is less than negative 2x plus 6. And then we want to get this y by itself. So go ahead and divide by negative 1 to everything. And when we do that, don't forget to switch that sign when we multiply or divide by negative. So that less than is now greater than. I get 2x and then minus 6. So this is the one we're going to graph here. Figure out what the b is. We know the b is y equals mx plus b. So my b is down here. Uno, dos, tres, cuatro, cinco, seis. Right there at negative 6. And then from our m, we got 2. Think rise over run. That's 2 over 1. We're going to go up 1, 2 over 1. Up 1, 2 over 1. Man, that was fun. That was your rise over run. Now I'm going to make the line, and because it's greater than, I'm going to do a dash line. I don't have that solid bar on the bottom, so it's not a solid line. And then last but not least, it's greater than. If I'm greater than you, I'm going up the number line. Okay, I always think of this like a totem pole. If I'm above you on the totem pole, I'm up here on the totem pole. If I'm less than, I'm below you on a totem pole. So my shading, my final solution, would be all of these x and y coordinate points above that line. And if you want to check your work, you could like take a point in that shaded region and see if it's true or false. You don't have to do this, but you could choose like the origin, which is shaded, and go, okay, is 0 greater than equal to 2 times 0 minus 6? And simplify, is 0 greater than negative 6? And the answer is yes, it's true. So that means I shaded in the correct direction. If you did that and you picked a point over here and it didn't work, it was a false statement, then we knew that we're not in the correct shaded region. Again, this is something you don't have to do. I always fall above and below, and you can too. So here we go. Example number 2, I've got x is greater than equal to 3y. Again, we want the y by itself, so I'm going to divide by 3. And now I have x over 3, or I prefer 1/3 x, is now greater than equal to y. Now, I don't know about you, but I like to have things written the correct way. We don't want it backwards like Yoda, or to see the dark side is. And we want to switch this around so that y and 1/3 x is over here. Now, if I look at my alligator, it's eating the x, so when I flip this all around, it should be eating the x. So now this is the equation I want to graph. So I'll go ahead and put my b, which is 0. I don't see anything back here. And then my slope is 1/3. So that means I got to go from b up 1 over 3, 1, 2, 3. If I want to do it again, man, that was fun. Up 1 over 1, 2, 3. Right. It is a equal to on the bottom, so I'm going to make this a solid line. So go ahead and make that a solid line through those points. Any point on that line is part of our solution set. And then I have a less than or equal to. If I'm less than you, I am below you. Less than has an L, that is below. So any of these answers, including the number line, the numbers on this line are part of my solution set. All right, so when we look at the backs, now we have a couple compound inequalities. So when we take a look, it says graph the intersection of x is less than or equal to 3 and y is less than x minus 2. So I'm going to go ahead and graph this guy, and if we remember our alphabet, U, V, W, X, Y, Z. When I have an x equals, that's on this side. So that means it's a vertical line. Or maybe you remember Vox, Hoi. Again, I have an x equals, in this case, x is less than or equal to 3. We know that's a vertical line. So I'm going to go ahead and graph that vertical line over 1, 2, 3 on the x-axis. It's equal to, so it's a solid line. But in this case, I can't do above and below because it's less than. So anytime I have a vertical line and I do less than is left, greater than would be to the right. So that arrow for the less than sign tells you which way to shade when you have that vertical. Okay, so I'm going to lightly shade to the right, or excuse me, to the left for less than or equal to. Then I'm going to graph this one. And I've got y is less than or equal to x minus 2. Again, my b is negative 2. 1, 2. And my slope, if I don't see a number there, I got to know that's a 1. So think 1 over 1. So I'm going to go up 1 over 1, up 1 over 1. Man, that's fun. We got rise over run. It is equal to, so when I make that line, it's going to be solid. Because I have that bar on the bottom, so make it a solid line here. And then I want the answers that are less than this graph. So in this case, less than is below that line, so I'm going to go below, 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 below. The last thing I want to do is take a look, and it was given that it's and is the intersection of the two. So and is intersection, so I'm going to go ahead and highlight where the blue and green come together. So I look, anytime I have two lines intersecting, I have 4 sections. This section has nothing. This section is only blue. This section over here is only green, and this is my final solutions right here. So right there is my final intersection. All right. Last but not least, we have example number 4. It says graph the union of x plus 1/2 y is greater than or equal to negative 4, or y is less than or equal to negative 2. So I'll go ahead and do this first one in blue here. The first thing I notice is this is kind of like standard form. This is not in slope intercept. So I need to get this into slope intercept form. So I'll go ahead and isolate this y by moving this x over using subtraction. Now I got 1/2 y is greater than or equal to negative x minus 4. The last thing I see is I got to get rid of that 1/2, so I can divide by 1/2, which is like multiplying by the reciprocal. And 2 over 1 is essentially like 2, so I'm going to multiply everything by 2. That way this guy and this guy cancels, and now I get y is greater than or equal to negative 2x minus 8. So I'm going to go ahead and graph that. I'm going to put my pencil on the B. We go down 1, 2, 3, 4, 5, 6, 7, 8. And then my slope is negative 2. Think negative 2 over 1. So here we go. I'm going to go down 2 over 1. You can also go up and to the left. Up is positive, 1, 2, and to the left. Up 2 and to the left, up 2 and to the left. And that's going to keep that negative slope. So going up is positive, but left is negative. That keeps that negative slope. Because it's equal to, again, I'm going to use a solid line when I make this guy. And then it's greater than, so my shading is going to be above. I'll usually do that lightly. The last one I'm going to do is y is less than or equal to -2. Again, going back to Vux Hoi, this is Hoi, or the alphabet, YZ. So we know this is horizontal at -2. So find the y-axis, count down, 1, 2, and then we're going to make a nice solid line going across. Less than would be everything shaded below. Below, 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 below. And then my final answer is or. So when I look at or means union. So my final answer is essentially putting these two shaded regions together. So anywhere that works for green, I would shade and darken in. Anything that works for blue, just blue, I would darken in. And then anything that works for blue and green, I would darken in. So the only thing that I would not have as part as my solution set would be this little area right there, what has no shading. Okay. So ladies and gentlemen, that is it for chapter or unit 2.5, graphing linear inequalities. I'll be back tomorrow or back on Monday, and you guys can ask questions on your My Math Lab. Guys, have a great night. We'll see you later.